So good morning, friends. So we are going to start the next module. Okay, module 3. So we'll have the recap what we have seen in the module 2. So parameters of transmission line. It means a single phase and three phase transmission line parameter we have seen, right? That too for single circuit and double circuit. How to calculate the transmission line parameter of resistance, inductance and capacitance for often solid, stranded and bundled conductors. Okay, so whether it's going to be of symmetrical spacing or unsymmetrical spacing conductor. Then how we are going to apply the concept of self and mutual GMD in your parameters of transmission. Okay, so and we have seen the various effects: skin effect, proximity effect, ferrantic effect, corona losses. Okay, so this is the first half of your module 2 we have seen, and second half module in the performance analysis of our transmission line. We have seen the performance analysis of our transmission line. For performance analysis, we have categorized the transmission line of an short, medium, long transmission line. So further, remember how to draw the equivalent circuits of our transmission line so that we can calculate the performance of our transmission line. So with that, with associated with that, we have seen about what is the attenuation constant and phase constant, then about the surge impedance. Okay, so the performance we have calculated in terms of transmission efficiency, voltage regulation and line losses. Okay, so after that we have seen about the methods of voltage control. It means a shunt and series compensation. Then the important topic of your calculation of sag and tension type of towers. Okay, so these things we have discussed in the module 2. Okay, so from today's session we are going to start with the module 3. So module 3 is going to be the first half we are going to see about the insulators, what we are using in our overhead transmission line, and the other type of transmission is going to be a cable. Because we have seen about the overhead transmission line, then we can use the underground cables also to transmit the power. Okay, so first we are going to see the types of insulator. What is meaning of insulator? What are the different types of insulator? We are going to see about that one. Then after that we are going to see about the cables, underground cables. Okay, what are the construction and how are the construction features of low tension cable, high tension cables. Okay, capacitance of single core cables, and these things we are going to discuss under the heading of our cables. Okay, so after that we are going to see one of the examples of your gas insulator substation. Okay, then we are going to discuss the distribution system. Till now we have seen about only the transmission part. So next we are going to see about our distribution system. You're going to see about the distribution system. So what are the different types of distributions are there? There are distribution systems are there. Okay, for AC distribution and DC distribution. Then we are going to see about in length, in elaborate, we are going to see the distribution system. So after that, we are having an introduction for our flexible AC transmission devices or transmission systems. Okay, so these things only we are going to discuss in our module 3. Okay, so before going into that, first just I want to recap what we have seen in that one, and we have to know about the syllabus, what we are going to discuss in the module 3. Okay, so we'll move to the first topic. The first topic is going to be of your insulators. First topic is going to be of our insulators. So what is the way of insulators? What is the way of insulators? So are you able to see my slides?
Yes, sir.
So the main part in our transmission is going to be of our insulators. Okay, so it's nothing but the live conductors must be properly insulated from the support. Otherwise, nothing but what will happen, nothing but the current will be flowing through the insulator. It means nothing but from the light conductor through the tower, it will be to the ground, flows through the ground, right? Okay, so the main thing here is going to be of the insulators. It means it should be live conductors should be properly insulated from your support. For that, we are using of the insulators. Okay, so here we are going to limit insulator. Electrical insulator is limit the material whose internal electric charges do not flow freely. Okay, which means therefore doesn't exert any contact on an electric current, or which under any influence there won't be of any flow of current. Okay, so but in practically we don't have of any perfect insulators. Okay, but some material has of glass, paper, and Teflon will have often high resistivity are very good electrical insulators that will act as often very good electrical insulators. Okay, so here we are going to use the insulators, right, to support and separate the electrical conductors without allowing the current flowing through themselves. So that is going to be the main purpose of our insulators. It means we the overhead line, the conductors should be supported by the poles only, correct? So in the last session of our module 2, we have seen about the type of towers. No, the type of towers in the which is going to be of nothing but will towers which used to carry the conductors. Towers are used to carry the conductors. It means the overhead line conductors are supported by the poles or towers. Correct? Overhead transmission line conductors are supported by of our poles or towers. Right? Such that our conductors carrying the current. Okay, that current should not flow to the earth through the support. That should not flow through the earth, flow to the earth through the support. So to avoid that, we'll use of an insulators. To avoid that, we'll use of your insulators. Okay. So when using the insulators, means it won't allow freely to move the current flow through the supports to the ground. Okay. So if the insulators are provided, but in the insulators which provides necessary insulation between the line conductor and support, that is going to call us of an insulator. It means they will prevent the leakage current from the conductors to the earth. They will prevents the leakage, any kind of leakage current. Okay, from the conductor to the earth, it will be prevented by the insulators. Okay, so when it's going to be from preventing the current to flow through the conductor, the insulator, then it should have some properties. Okay, so the main property of our insulators means the first is going to be of your mechanical strength. The mechanical strength, right? Why? Because it has to be carry the conductor weight and the wind pressure, wind load. Okay, so that the insulator should have often high mechanical strength. Insulator should have often high mechanical strength. Why it is needed means, but in order to withstand the conductor load and the wind load, right, etc. You can say whatever it may be. Okay, you can, but it has to be withstand. Okay, the first property of our insulator, the first property of the insulator, but it should have often high mechanical strength. It should have often high mechanical strength. Why it needs often high mechanical strength? In order to withstand the conductor and the wind load. Okay, so that it need often high mechanical strength. Second thing is nothing but high insulation resistance. It means nothing but to avoid the leakage current to the earth. To avoid the leakage current to the earth, right? The insulator should have often high electrical resistance. It should have often high electrical resistance. Why it should have often high electrical resistance? Means it should not to avoid the leakage current to the earth. Okay, so third thing is going to be but high dielectric strength. It means but it should have often high but dielectric strength. So when it has often high dielectric strength, means the puncture to often flashover is going to be often less. It will have often high ratio. Okay, so that is going to be often the but that be here we are calling often high dielectric strength. Then only the it will be act as often very good insulator. Then only it will be acting as often very good insulator. Then next thing is going to be of your high relative permeability. High relative permittivity. It means nothing but if it has often high permeability, so that the high dielectric strength will be of your high. Dielectric strength will be of your high. Next thing is nothing but it should be free from porous and impurities and cracks, right? Free from porous. It means it should be the insulating material should be of a non-porous, right? And free from impurities. So what will happen if you have often porous means it become often conductors. At higher voltage it become often conductor. If it have often impurity in the but if you have often impurities means that become of semiconductors due to of the potential gradient but potential become often conductor. Okay, the breakdown may be happen. So that's why insulator material should be often non-porous. Insulator material should be of your non-porous and free from impurities and cracks. Free from impurities and cracks. Okay, and at any cost, it should not be get affected with respect to the temperature. Okay, so when we use based on this property, if you see the normally most commonly used material for the insulator here is going to appear porcelain. Okay, so which satisfies all the property of this whatever the properties which I have told. So these properties will be there. Such a one of the material here is we are going to use this for the insulator here is going to appear porcelain. Okay, but you can use because as I have told you here I have told you here the glass, paper, and Teflon. Gas, paper, and Teflon. I have told here act as often very good insulators. Okay, see here, I have told you the glass, paper, and Teflon, right, which have often high resistivity and are very good electrical insulators. Okay, but the most common used material which satisfying these properties. Well, what are the properties mean? The insulator should have often high mechanical strength. It means it should have often high mechanical strength to withstand the conductors. That's why we are having often insulator should have often high mechanical strength, right? And it should have often high electrical insulation or resistance. Okay, and high relative permeability, so that it will have often high dielectric strength. Okay, and it should have often free from impurities and your porous. Non-porous should be often non-porous, right? And apart from that, it should have often high ratio of puncture strength to flash over. That we'll see in the what is a punctures to often flash over. Okay, so which satisfy the material which satisfying these properties, but the most commonly used insulator here is going to appear porcelain. Okay, but we can use the glass also. But we can use the glass as a special combination material also used to laminate in some extent with their insulators. Okay, so so here how we are going to produce this porcelain means we'll firing at high temperature, right? With the mixture of choline and as well as of your field spray and cortex, we are producing this porcelain. Okay, so that's why here this material will have often strong, but it will have often strong mechanical than your glasses and gives less troubles from your leakage current. Okay, and at any cost it won't, the change in temperature affection will be often very less. So that's why all the insulators whatever you are using in our transmission line is going to appear porcelain insulation. Okay, so based on the application what we are using the insulators, we are classifying the insulators as often 4 different types. We'll have different types, but majorly the commonly used insulators are classified as often 4 types. Okay, so first one is going to appear pin insulators, second one is going to appear suspension insulators, third is going to appear strain insulator, and fourth is going to appear sackle insulators. Fourth one is going to appear sackle insulators. Okay. So this is very important for overhead transmission because but the support which carries the conductor, it cannot be able to place directly on your towers. Okay, what will happen if you place it means but it will be grounded directly. Okay, so then the current will be preferred to flow through of your low resistance path. Current will be preferred to flow through of your low resistance path. Okay, instead of the conductor to the tower to the earth, it will be flowing. So to avoid that, we are placing the insulators. It means it has to carry the conductor. Okay, it means it will provide the necessary insulation between your line conductor and the support. Okay, for that purpose only we are using of the insulator. The most common insulator here what we are using is going to appear porcelain. Okay, we can use the glass also, but the porcelain is going to be the most used insulators in our overhead transmission line. So here in the we'll have the different types, and the most commonly used types are here is going to be of a pin type. Second is going to be a suspension type of insulators. Third is going to be a strain insulator, and fourth is going to be a sackle insulators. Okay, so we'll see one by one what is the different type of insulators. Okay, the first one is going to be your pin insulator, and this shows your pin insulators. This will shows your pin insulators. Okay, so normally these pin insulators will be placed on over your cross arm. I think in the but we seen the type of towers. No, we have seen the different type but different type of towers. Right, in the tower we'll have often cross arms will be there. So if you're having often tower means the tower will have often but horizontal, that the horizontal arm is the that is going to be called as of your cross arm. That is going to be called as of your cross arm. So in this cross arm, if you place the insulators over that cross arm, that is that type of insulators here normally will use of your pin type insulator. So it will be in this insulators will be secured on your cross arm on the pole. Okay, so normally here this type of insulators will be called as of a pin insulators. Okay, the pin insulators is nothing but it's a non-conducting material will be having of it will be composed of your porcelain, glasses, plastic, polymer, or maybe wood. But so normally here the pin insulator, the insulators all will be made up of your porcelain only. Okay, see here I have told you here, but it will be secured. It will be secured to the cross arm. Suppose here in the middle I am having of the transmission pole. Here I am having of an transmission pole. Suppose I am taking of an A type of pole, I am taking it out. Okay, I am placing a cross arm here. Okay, in the cross arm, right? So this insulators will be placed at this point, and it will be screwed on the cross arm. It will be screwed on the cross arm. Okay, so but and there is a groove on the upper end of the insulators for the housing of the conductor. It means but we have to place the conductor over the here I have to place the conductor. Conductor has to run over these insulators. Okay, so to place in the conductor there will be often groove. So this you can see here. This is a groove. A cut section. You can able to see this cut section. No? You can able to see this cut section. No? So this cut section, you can able to see a cut section here. No, so in both sides, see here a cut section is there. Okay, so in this cut section, the conductor will be placed over this one. Okay, the conductor will be placed over through this groove, and it will be often tied, and it will be affair tied so that at any cost, the high wind pressure, it won't be come out from the insulator. Okay, so this nothing but there is a groove on the upper end of the insulator for housing the conductor. Okay, so here the conductor will be passing through this groove. So here the button, suppose I'm having the insulator, these insulators, the conductor will be passing through this groove and is bounded by a annealed wire, right, of same material of the conductor. So it will be often tied. It will be often tied with that one. Okay, so normally this type of insulators will be used in our transmission and distribution up to the voltage of 33 kilovolt. Okay, 33 kilovolt. Suppose if you want to use this type of pin inserters more than this 32 kilovolt, right? So that will be often bulky. It will be often too bulky, and it will be often uneconomical, and it will become often uneconomical for larger power transmission networks. Okay, so that's why here with pin insulators will be used for a maximum of an 33 kilovolt of transmission and distribution network. Okay, see here. So normally this type of pin insulators normally will be used for often 11 kilovolt. It means for your low transmission voltage of 11 kilovolt, or for the distribution networks. In the distribution networks, we are using of here this type of pin insulators. Okay, so 11 kilovolt to often 33 kilovolt, we'll use this type of pin insulators. We'll use this type of insulators. So you can have a question how this will be placed on your cross arm. So in the lower part there will be of nothing but metal rod will be there. In this metal rod will be there. So this metal rod will be placed on the cross arm, and it will be screwed so that it will be tightly fixed on your cross arm of the pole. Okay. So here, but this type of pin insulators will use the maximum transmission and distribution voltage of your 33 kilovolt. Okay. So here the cause of insulator's failure is going to be often there. Okay. So it means our but I first thing I have told you the property of the insulators and the but insulators requires often high withstand. It means both the mechanical and the electrical stress. Okay, so mechanical strength is going to be often primarily to do of your line voltages and may cause us the breakdown of our insulators. Okay, so electrical breakdown means here remember the electrical breakdown in the insulators normally either with respect of the flashover or puncture. Flashover or puncture. Okay, so insulation. This insulation also will be get failed. Insulation failure will be there. So what is the insulation failure means? There will be often two type of insulation failure. One is going to be often mechanical due to of the mechanical stress. There will be often insulation failure will be happen. Okay. Another thing is nothing but electrical stress. Due to the electrical stress also there will be often insulation failure will be there. Okay. So mechanical stress nothing but is nothing but primarily that is going to be often due to of the line voltage and may causes the breakdown in the insulators. Okay, but the electrical breakdown occurs either with respect of the flashover or puncture. Okay, so what is the flashover? The flashover is nothing but the arc which is going to be often occur between the line conductor and the insulator pin. So I have told you nothing but so this is going to just need to understand. I will change the color. I will change the color. Okay, so this is nothing but where we are placing. See here, this is a groove. This is a way hanging of the groove. So in this groove only, we will placing of the conductor. We are placing the conductor in this groove. It means it's inside. Just I draw the line outside. Okay, this is going to be of the pin. Here we will be having of your pin. Here we will have the pin which is going to connect to of your crosser. Okay, what is a flashover means? An arc, in the arc which is going to be often occur. It means the arc which is going to be often occur between your conductor and this pin. Between this conductor and the pin, insulator pin. So that is going to be of called as of your flashover. That is going to be called as of your flashover. Okay, so this there will be of the discharge will be jumps from the air gap flowing to the shortest distance. So that is going to be called as of your flashover. Okay. So what is the arcing distance? Suppose here you see here in the arcing distance means but I'm having of the disk here. Okay, so this is going to be of your A, and this is going to be I'm calling this of the gap air gap. I'm calling this of this is going to be of my B. Okay, and from here to pin this is going to be called as of my C. Okay, and this is nothing but where we are placing of our crosser. Okay, it means when the arcing distance means the arcing distance will be equal to but A plus B plus C for often this type of insulators. Okay, so the discharge which is going to be often jumps from the air gap and flows through the shortest distance that is going to be of your flashover. Okay, so flashover is nothing but the arc which is going to be often occurs between your line conductor and the insulator pin. The thing that is going to be called as of your earth. That is going to be called as of your flashover. Okay, so this is nothing but is going to be of nothing but flashover. What is the puncture means nothing but? So here nothing but if the discharge occurs from the conductor to the pin surface, if this pin surface, but this air gap is going to be often get ionized. Suppose if this air gap is going to be often get ionized, okay, and there is of taking of the chance for flowing of the gap, and but it's going to appear flow of current. So if the discharge happens between from the conductor to the pin surface, pin surface, it means insulator pin. So this from here to here, and from here to here, from here to there, and then to the pin. Body of the if the pin through the body of the insulator, then that is going to be called as of your puncture. Okay, then that is going to be called as of your puncture. Whereas the two things is going to be very, very important in your insulators. One is going to be of your flashover and puncture. Flashover and puncture. If there is of an arc which is going to be between of your conductor and your pin to the earth, then that is going to be called as of your flashover. So puncture means remember the discharge occurs from the conductor to the pin through the body of the insulators, through the body of the insulators. So that is going to be called as a puncture. Okay, so when flashover occurs means the insulator will act as often insulators only. Okay, but when there is often punctures mean then the insulators will be permanently destroyed. Okay, due to of the excessive heat, because it's 11 kilovolt. Suppose in case of 33 kilovolts, there will be of an excessive heat will be there. So when the excessive heat, this loses its property of dielectric strength. So automatically what will happen, nothing but that become often puncture permanently. So then we have to replace the insulators. Then we have to replace the insulators. Okay, so if we want to avoid the punctures, means nothing but we need to provide the sufficient thickness. See here, nothing but the sufficient thickness has to be provided. Okay, we need to provide often sufficient thickness. See here, this thickness, the disc thickness. See here, so this thickness, the disc thickness. Okay, so if you want to avoid the puncture in your insulators, means nothing but the insulator should have often sufficient thickness of the porcelain, so that we can avoid the puncture due to of the line voltage. Due to of the line voltage. Okay, so here in the insulators, the two important thing is going to be often what is going to be often flashover and what is going to be of the puncture. So flashover is nothing but the flashover here is going to be of is nothing but is an arc which is going to be often occur between the line conductor and the insulator pin. That is going to be called as of here flashover. Okay, so what is of the puncture here is going to be of nothing but the puncture is going to be the discharge which is going to be often occurs from the conductor to the pin to the body of the insulator. That is going to be called as of here puncture. When there is often nothing but such a breakdown, it means through the body of surface means then there is going to be called as of here breakdown. If such a breakdown is going to be often involved, then the insulator will be permanently is going to be often destroyed. Permanently will be of here destroyed. Why? Due to of the excessive heat. So then we have to replace the insulators. Okay, when the puncture happens, then we need to replace the insulators. Suppose if you want to avoid the puncture to happen in your insulators, means then the insulator should be provided with the sufficient thickness of porcelain. Okay, so then we can avoid the puncture. That sufficient thickness depends upon the voltage level. The thickness maybe often gets varies. Thickness maybe often gets varies. Okay, so next thing is going to be of the safety factor. The next thing is going to be of your safety factor. The puncture tends to the flashover voltage, nothing but that is going to be called as of your safety factor. Okay, here we are going to with these insulators, we can able to describe what is a safety factor. So safety factor SF. The safety factor is nothing but that is going to be called as of your puncture to of your flashover. Puncture to of your flashover. That is going to be called as of your safety factor. Okay. So normally for this type of insulator, the safety factor will be of your 10. Okay. So normally the desired factor will be often high. So what will happen if it's high means so the flashover will be take place before the insulators gets punctured. Okay, so the insulators will not get damaged. Insulators will not get damaged. So that's why here the safety factor should be often high. So normal for pin type of insulators we'll use will have often safety factor of 10. Okay. See here. So this is going to often the parts of your insulators. See here how it's going to often grooved. So we'll have for the conductor. So this is your any doubt? So this is your conductor. That conductor will be placed in the groove. See here the groove, which is the groove for the conductor, and this this disc side that is going to be called as a shed or petticoats. Okay, and the layer of that's going to be called as a cementing, and the pin which is should be there in your insulator pin insulator. Then only it can be able to groove in your crosser. Okay, that pin normally will be often galvanized steel pin. That will be a galvanized steel pin, so that will act as an insulator, so it won't conduct. Okay, so say the same material will be and it will be that wire, so that is going to appear as we will tie it up. Otherwise the limit will be come out from your insulators. Okay, so this is your pin type of insulators. So in pin type of insulators, how we need to know about what is the causes for your insulation failure. Causes for your insulation failure. So there you have to know about the definition of what is of flashover, what is of the puncture, and what is of your safety factor. Okay, so these three things are going to happen very, very important in your insulators. So next thing is going to appear suspension insulators. This is going to appear suspension insulators. As I told, we can able to make the insulator by using of the porcelain materials. Okay, which is acts often very good dielectric strength and your high in the but porcelain is going to has of a high dielectric strength and high mechanical strength. So that's why we normally will use often commonly used is going to be often porcelain. So these images will remember the whatever here I am showing here. This is going to appear porcelain material, and this image. So this type of image, so it will be of a glass type of insulators. We'll use the glass material. Okay, so making of here insulators. Okay, so we can able to make a glass type of insulators as well as of here porcelain material insulators. So suspension type of insulators. So normally here, as we know that in pin insulators, the cost of the pin insulator is going to be often increases. Okay, so in your pin insulators, based on your cost. Okay, so cost is going to be often divided in pin insulator. The cost is going to be often increases. How it's going to be often increases means with the voltages, with your working voltages of your transmission line. If the voltage increases, right, your cost for your pin insulator also is going to be often increases. Okay, so that won't be often economical for higher voltages. It means if the voltage is going to be often greater than your 33 kilovolt, if it greater than 33 kilovolt, okay, so our pin insulators is not going to be often economical. Okay, so but for making this often practice of but having often lesser cost with high mechanical strength and dielectric strength, we'll go for often suspension type of insulators. Oh, right, so where nothing but so number of porcelain discs depends upon the voltages. Number of porcelain discs is going to be often connected in series through the metallic links. So that forms often strings. That forms of your strings. Okay. See here. So for higher voltages, it means about for often 33 kilowatt. It usually okay. So number of porcelain discs is connected in series by the metal links. So that is going to be the that forms of your strings. So here, but the in the but we in the but the conductor here, the conductor will not be placed. Conductor will be hanging with the help of the insulators, and the insulators will be hanged on the cross arms. Insulators will be crossed on your but hanged on your cross arms. Okay. So here the conductor is suspended at the bottom of or bottom end of your string, while the other end of the string is going to be secured to the cross arm of your tower. Okay. Here the each disk. See here, this is a one disk. This is your one disk. See, this is a one disk. Okay, so this is a glass disk and glass type of insulator disk. So this is also one disk. This is also one disk. So likewise, the n number of disks will be often connected. Here, the each disk. Here, each disk will be designed for often voltage of 11 kilovolt. It means one disk can have the capacity of 11 kilovolt. Okay. Suppose it's going to be often nothing but 33 kilovolt means nothing but we'll have often 3 disks. Suppose it's going to be often 110 disk means nothing but 110 kilovolt means we'll have often 10. Okay. Suppose if our working voltage is 66 kilovolts means then we'll have often 6 disks will be there. Okay. So that will be placed in these things. Okay. So number of disks in the series will be connected depends upon the working voltage. Depends upon your working voltage. See here, each disk will have a low voltage of but designed for a voltage of 11 kilovolt, and the number of disks in the series is obviously depends upon your working voltage. Suppose if your voltage is going to be often 66 kilovolt means okay, then 6 disks are needed that has to be connected in series. So that provides the often string. That provides of your string. So here you can see. So you can see here this for often 33 kilovolt. So we have often 3 this will be there. See here, this is a cross arm. This is your sorry. This is your cross arm. This is your cross arm. Okay, this is your cross arm. So this cross arm will be on your tower. This will be on your tower. Okay, fixed. So if the unit semi clamp will be connecting the. So we will connecting the disc one. If now depends upon the voltage of the transmission line. Okay, that is number of discs is going to be often more. Number of discs will be of here more. Okay, so where nothing but we are connecting where we are connecting of our transmission line conductors at the bottom of the disc. The bottom of, so it will be often hanged. It will be of here suspended. Well, that's why here this type of insulator here is going to be called as a suspension type. It means the conductor is going to be often suspended at the bottom of the disc or this string. Okay, and the other one is going to be often other end of the disc will be often suspended on your cross arm. That's why this type of insulator here is going to be called as here suspension insulators. Okay, so normally when your voltage is going to be often higher, we'll used to prefer to go for a suspension type of insulators because they will be often cheaper for the voltage behind often 33 kilovolt. Behind 33 kilovolt, it is going to be often cheap. Okay, suppose any damage to the insulators. Suppose this insulator number one disc is going to be often gets damaged. So this center disc, suppose the center disc is going to often gets damaged, means I don't need to change the complete string. Okay, so only I can remove this center disc and I can replace the new one. Okay, so the maintenance is going to be often easy. Maintenance will be often easy. Okay, so and this type of suspension arrangements that makes often greater flexibility to your line. So that's why here we'll use often suspension type of insulators for the voltage behind often 33 kilovolt. So normally for higher power transmission, whenever the voltage level will be often higher, so we need often additional insulation. That additional insulation we can obtain from your suspension arrangement. Okay, and it depends upon the voltages, number of discs is going to be often increased. Number of discs is going to be often increased. Okay, so normally the steel tower, I think in the last session of the module 2, we have seen about what are the different type of structures, but we have seen about the type of towers. So type of towers we are classified as often two major categories. One is going to be of an electric pole, another one is going to be of an electric tower. Okay, so the tower, the steel tower which we are using, there we'll use to go for often this type of suspension type of insulators. So when you're using this type of things, nothing but so suspension type of insulators, the conductor will be of a suspended under the bottom of the lower disc. So that provides a partial protection for your lighting. That is one of the main advantage here also. We can speak in terms of advantage. Advantage means the low cost compared of a pin type of insulators. When your working voltage is going to be often higher, we'll use to prefer for of your suspension type of insulators. We'll prefer to go for a suspension type of insulators. Okay, and second thing is nothing but so it depends upon your voltage level, you can add the number of discs. Okay, if any one disc is going to be often damaged, then we can replace very easily. Okay, and it will provide more flexibilities. So that's why we'll go for often suspension type of insulators for your higher voltages. Okay. Next one is going to be appear strain insulators. So any doubt? Any doubt? Students, any doubt? I need some response. Okay. Abhirami, Janani, Dinesh Kumar, Rupan, Sridhar, Hariharan. Okay, good. I think you are in line. So till now, Sumant Reddy, okay. So till now we have seen about the Insulators. What is mean of an insulators? What is the different type of insulators? In that we have seen about what is a pin insulators and what is mean of your suspension type of insulators. Okay. So this is but because insulator is very important in your overhead transmission. Because we don't need of an insulators for our underground cables. Okay, so that is a different type of construction of your underground cables. We'll discuss after this insulator part. We are going to take about your underground cables only. Okay. So pin type of insulators normally will be used for your low voltage. Okay. And your suspension type of insulators will be used for voltages more than 33 kilovolt. Okay, more than 33 kilovolt. Okay, so normally when you are using of your when you are using for of your higher voltages, when you are using for your higher voltages, it means where you are having often steel structured towers. Okay, so there we'll use to go for of your suspension type of insulators. There we prefer to go for of a suspension type of insulators. Okay, so next thing is going to be of our strain insulators. So strain insulators, this limit you can see this image, right? You can see this image, right? So this is your strain insulators. These are your strain insulators. Okay, this will be of your strain insulators. So whenever there is a dead end of your line, or there is a corner, or there is of your corner, or your sharp curve, right? So at that point, the line will be subjected to often greater tension. Okay, so for to relieve the greater tension, so we'll use of your strain insulators because at the end of the transmission line, we need to conductor has to be tied. Okay, because the entire length will be lying on your last one. Okay, so that's why whenever there is a dead end of the line or there is a corner or a sharp curve, right? So normally the line will be subjected to the greater tension. Okay, so if you want to relieve this tension means then you have to use these strain insulators. Then we have to use the strain insulators. Okay, so for when the voltage level is going to be of less than 11 kilovolt, normally we'll use the cycle insulators of your strain insulators. But for your higher voltages, the strain insulators will be assembled as a like of suspension insulators. Assembled like of your suspension insulators. Okay, when there is a tension on the line is going to be of an exhaling high. Okay, so then we need to go for of the strain insulators. This type of insulators will be also called as of strain insulators, or the higher voltages will use the suspension type of insulators as of your strain insulators, and that will be tied to the ground through of your guide wire. Okay, tied through of your guide wire. Guide wire. Okay, so that is going to be a strain insulator. See here, when there is often dead end of the line, there is a corner or sharp curve. So there will be high strength will be there. Okay, then we have to go for of your strain insulators. Okay, for higher voltages, the strain insulators were assembling of your suspension insulators. So that I will show you how they work. Okay. So normally this will be in your vertical. This will be of strain insulators will be of your vertical. Okay. See here. So this is your strain insulators. This is your how higher voltages will use of these strain insulators, like how we are placing the suspension insulators. Similarly, there is going to be often vertically it will be often placed. Okay, and this will be often grooved strongly to of your electrical towers. Screwed strongly to of your electrical towers, and this insulators, this type of we have but insulator scale is going to have called as of your strain insulators. That is going to be called as of your strain insulator. So these are also strain insulators. So this type of for lower voltages we will use this type of insulators. This is going this also is going to be called as of your strain insulators. Okay, so either you can use this type, okay, or you can use this type also. You can use this type also, or you can use this type of also. So normally this one, this type of insulators, remember this which I am showing here right now. So this will be used for stay away. Like electric pole is there, no, to but support your electric pole that will be often tied through of and stay away. But the giveaway. So there we'll use this type of insulators. Okay, that is going to be called as a strain insulators. Okay, so this also you can call as of your strain insulators. This is also is going to be often called as of your strain insulators. Okay, where we have the poles. So I told you, but where do you have one sharp curve or maybe of your, if we have one sharp curve or maybe of the corner, there if you want to use means then we'll use of this type of strain type of insulators. We'll use of your strain type of insulators. So normal in case of nothing but low voltage, this strain type of insulator, there we are calling of a Sackle insulators. There we are calling of a Sackle insulators. Okay, so that will be also used at the end of your transmission line or nothing but where there is often curve or sharp corner is there, then we can use it out. So okay, so that type of insulator that is going to be called as a Sackle. This is going to be a Sackle insulator. This will shows of your the image shows is a Sackle insulators. So the neighbor that will be insulator is going to be normally mounted axially. Okay, so neighbor the circumferentially there will be often grooves. This circumference, this circumference, whatever this circumference here is the neighbor. So this neighbor will have of here neighbor grooves will be there. So where the completely the limit is going to often takes the load, okay, of your conductor position. So here this type of insulators normally bolted to of your cross arms. See here. So in the early days, exactly insulators were used as of your strain insulators, but nowadays frequently used for your low voltage distributions. Okay, it can be placed either horizontally or it may be placed as of your vertical position. So that is going to be often things. Okay, so this is your Sackle type of insulators. This is your Sackle. See here, this is a Sackle type of insulators. This is your Sackle type of insulators. We'll have of anything but metal. We'll have of here metal rod will be there that will be carrying will be of metal pin will be galvanized metal pin will be inside your Sackle insulators. Okay, and the conductor will be grooved on the out near circumference. Near circumferential grooves will be there on the insulators that will never be placing there, and that near this bolt, this strap is going to be often connected to the pole through of your metal screw. Okay, so this is your Sackle type of insulators. So just I'll show in videos. So I will stop sharing this one. Okay. So I'll give you a live example. how a suspension type of insulator is going to be often replaced. So this is our tower. Okay, electrical tower. So base of the electrical towers. So this is the black color which we are seeing is the image is going to be a suspension type of insulator, but here there is going to be called as of a strain insulators because they are having often curvature. That's why they are using this type of insulators. Okay, that is going to be a strain insulators. Okay, so now they are going to replace that punctured insulators. So before whatever they are going to do of an electrically, nothing but so line conductor may be of nothing but discharge, but there won't be of a complete discharge. For complete discharge of your electrical line, they will use the earth rod. They will use the earth rod so that they can discharge the charges which is available in the conductors. Even if the line is going to be disconnected, there may be often charges will be there. So it means that should be often grounded. See, this is going to be a suspension type of insulators that will be here using a often strain insulators. Okay, so they are going to replace this but punctured insulators. So then they are but testing the insulators but what is the actual potential. So that is going to be of the jumper wire. Now, I have shown the diagram. No, the strain insulators in the where you need of the curvature means there will use of the jumper wire. That jumper wire only they are moving it out. That is your jumper wire. So this is going to affect the insulator. So depends upon that, but since it's going to be a 33 kilowatt live tension, no, that's but they're using for often stain suspension type as often stain insulators. But this is going to be appear the line how it's going to be line or conductor is going to be often grooved with the, and this is going to be of the jumper. So this one is going to act as such a jumper. So this is how they will replace the, if the puncture has happened. Flash out means but they will be act as often but insulator. But when puncture has happened means then we have to replace that insulators. Okay. So that only they are doing out to replace the puncture one. Okay. I'm stopping here. So now we'll come back to our session. So any doubt? So any doubt with the types of insulators? So we'll have often 4 types of insulators: pin insulator, suspension type of insulator, saddle insulator, and your strain insulators. Okay, so we are having often 4 different type of insulators. So here the insulators, normally insulators in the ring, but it should insulate the, our insulation should be provided between the live conductor and the support. For the purpose only we are using insulators. Okay, it means any leakage current in the conductor to the earth should be avoided. So that's why we are using of the insulators. So if you want to use many materials of an insulator, it should have some properties. It should have some properties. The first property here is going to be of nothing but for the insulator, it should have often high mechanical strength. Second thing is going to be often it should have often high electrical resistance. Okay, that should be to avoid the leakage current. Okay, and it should have often high relative permeability, right? So that have often high dielectric strength. Okay, so and apart from that, the insulator material should be non-porous and free from impurities and cracks. If it have the porous or but impurities means then that become often semiconductor with the voltage that become of your conductor, higher voltages. Okay, and it should have often high ratio of the puncture strength through the flashover. So these are the required property for an insulators. So based on that, normally here we are using often 2 different type of material. One is going to be of the porcelain or other one is going to be of here glass. okay, with a special composition. Whereas glass won't have often high mechanical strength. So that's why we'll use of the composition to become limit make it is often more mechanical strength. Okay, so most preferable or commonly used material for your insulator is going to appear porcelain material. Okay, so based on the application and the type of thing, we have categorized the insulators of your pin insulator, suspension insulator, strain insulator, and the sackle insulators. Okay, and the sackle insulators. Okay, so this is going to appear in the but what are the different type of insulators? Okay, so next thing important thing in our insulator here is going to appear voltage distribution. How about the voltage distribution in a insulator string? So this is going to be called as of your insulator strings. This is going to be called as of your insulator string. Okay. So this is going to be called as of your insulator strings. So this part, this is our insulator string. Okay. So normally, but that will comes in your suspension type of insulators. Okay, so number of how many number of porcelain discs are going to be often connected with the metallic links that will form the strings. This will be called as of your strings. Okay, so in but here if we see here in the but between the but each portion of the disc here in the but there will be often two metallic links in there. So this is going to be often one metallic links and this is going to be often one metallic links. Okay, so normally we know what is a capacitor. What is BFN capacitor? How we are going to make a capacitor? Anode and cathode separated by F1 dielectric medium that is going to be called as of your capacitor. Okay, capacitor it means nothing but capacitor is nothing but anode and cathode separated by F1 dielectric medium that is nothing but we call as of your capacitor, which can have the property of storing of your energy in the form of electrostatic field. Okay, similarly in the suspension type of insulators, then but in a string of insulation, not a single disc. I am not speaking about a single disc, but a string of suspension insulators. It means number of porcelain disc is going to be often connected. How it's going to be connected means, but so this is going to appear one disc. See here, this is going to appear one disc. Okay, this is going to appear one disc. So we'll have often screwing connections will be here, and but this will be connected to the other one. Okay, so if I connect but number of discs, but if the portion of the each disc is going to often is in between of your metallic links level. Okay, so this only here in the middle I am calling software in the middle. Each disk here in the middle, the each disk. Suppose I am taking up this disk. So disk one, this is going to be of my disk one. Okay, so this is my porcelain. This is my porcelain. But here this is going to be of the arrow mark which I have denoted here. This is going to be of metallic links. This is going to be of metallic links. So this will forms a capacitor. So this will forms a capacitor. Okay, and each disk forms a capacitor. Each disk is going to forms a capacitor, and this is known as the area mutual capacitance. This is known as of a mutual capacitance. Okay, so here nothing but this is going to be the mutual capacitance. But so this capacitance here that is going to be called as of here, right? That is going to be called as of a mutual capacitance. I can try and even draw this capacitance. Suppose I am the disk one. This disk one I am this is going to be called as a capacitance, which is going to happen conducted through of a string. So that forms of metallic and flow of current. So the disk one. This is going to be of my disk 2. Okay, this is a 2 disk 2 and this is my disk 3. So there will be an but between the metallic links and the insulator, this forms of a capacitance. Okay, so this is capacitance, this is going to be called as of a mutual capacitance. This is going to be called as of a mutual capacitance. But what will happen where we are suspending this one, this is a cross arm. We are having of this cross arm. So this I can able to draw this as often cross arm. This I can draw as often cross arm. So this is going to be of my cross arm. See, I'm writing here, this is going to be a cross arm. Okay, and this is my conductor. This is my conductor. So the light conductor is going to be often connected at the bottom. Okay, so where this cross arm is going to be often placed, this cross arm normally placed on the tower. So this the cross arm is going to be connected with respect of your tower. Okay, so but this is a cross arm where we'll have of the towers will be there. This is going to be often act as of your towers. So this is going to be your tower. Okay, so this is going to a tower, but in our but so this is a tower, and this is going but there will be a metal but see this is going to be the metallic links. This is going to be this is going to be a callings of the metallic links which connects your disc. Okay, so air is of a medium, air is going to be a dielectric medium. Okay, and there is often two metallics. One is going to be the tower and your insulator, which is going to have connected to the other insulator. Okay, so that is going to be a metallic. So there is a exists of a capacitance. So this means if metal fitting of the each disc and the tower, so there will be of nothing but capacitance also exists. That is also capacitance also going to often exist. Each metallic links to the metal fittings of the each disc and the tower, there is exist of a capacitance. So that capacitance that is going to be called as of a shunt capacitance. That is going to be called as of a shunt capacitance. Okay, so because air is of medium, though anode and this is another one acts as a cathode. So there is air is of medium with the higher potential, there will be of ionization that forms the charges. Okay, so this exists of your capacitance. So it means this metallic links and the tower there will be of capacitance. So this capacitance, I will change the color. Okay, so this capacitance, suppose this is going to be of the capacitance, this is going to be this capacitance. So this is going to be of capacitance exists between the metallic links and the tower, and these metallic links to of the neighbor, there will be of your capacitance going to exist. Okay, so this is going to be called as of your shunt capacitance. This is going to be called as of your shunt capacitance. Shunt capacitance. Okay, so it means due to this shunt capacitance, there is a charging current, and this charging current is not same all through of your disc of strings. So because the current in this disc is going to be of not same with respect of the current in this disc. But if there is of no metal, if it's suspended means only I will have of here only I will have often strings of limit capacitance. So the current will be of an uniform. Okay, current will be of an uniform. So voltage across the disc will be of here evenly distributed. But when this capacitance is there, sorry. So why I have taken the suspension type of insulator something, but how about the voltage distribution in these strings? Because I have shown you a video, but they are checking what is the potential difference across the disc. Okay, if it higher, then it's going to be but if it's going to be but potential distribution is going to be based on that, we can able to analyze the puncture. If a higher the potential difference in the but then there will be of but flash over or puncture may happen. So then we have to replace the disc. Okay. So in that video, how after climbing they moved the cross wire. They moved the jumper away so that there won't be a free discharge over the persons. Then they are using the check the voltage potential difference across the insulators now. So why they are checking whether they are due to the flash or puncture, the insulator get damaged or not, right? So that how to study the voltage distribution across the strings of insulators only we are taking the voltage distribution in the insulator strings. Okay, how that is voltage distribution is going to happen to analyze that one nothing but I have taken this example of suspension type of insulators. I have taken this suspension type of insulators. If you take the suspension type of insulators, this is a metallic pin. This is a metallic pin. See here, this is going to be of our metallic pins. And here there will be often one metallic pins will be there. So in between these metallic pins only there will be often a porcelain disc. It will be of your porcelain disc will be there. Okay. So this porcelain disc in between the two metallic links. So that here electrically we are calling that is going to be of your capacitance. That is going to be called as of your capacitor. Why? Because what is a capacitor? Anode and cathode separated by a dielectric medium that is going to be called as of your capacitor. Okay, so but metallic links, one will act as of another will be acting as of your cathode. Okay, and the process whenever there is a puncture pressure, the ions will going to be often as air is often medium is there, no, will be often due to often higher voltage it become often ionized. So the charge is going to be often accumulated. Okay, so nothing but that's why here but each disk will be but here it's forms of a capacitor. Each disk will forms of a capacitor. Suppose here I am having often three disk. Suppose I'm having often three disks. So but with the cross arm, I can draw the capacitance going to be often but C1. This is going to be of one capacitor, and this will be of here another capacitor, and that will be of here another capacitor. Okay, three capacitors will be there. So but since this but this suspended directly, this is going to be this I am going to be called as of here C, and this is going to be of my C, and this is going to be of my C. And since there is of but this is going to be called as of a self capacitance, the current flowing is going to be often same. So automatically the voltage distribution here is suppose the voltage here is going to be often. Suppose here the voltage I have taken here is going to be of my, this is a voltage across from this this is a voltage across my first cross arm 2 of the line tip. So this is going to be of an voltage V means, so this voltage is going to be of an uniformly distributed V by 3. So 3 discs are there. So that is going to be of an but V by 3, and this is going to be of an V by 3. Okay, it's going to be of an uniformly distributed. But if you are hanging off on the tower will the cross arm will be fixed on your tower. So there will be of this tower is a metal, and the pin, this pin will be metal. So this pin and this metal, this pin and the tower metal. So there air is often medium, there will be often sun capacitance will be there. There is often medium, there will be often sun capacitance will be there. When there is often sun capacitance, the current will be often not uniform. It won't be often uniform. It won't be often uniform. Okay, so then the voltage across the disk will be often different. So voltage across the disk will be often different. Obviously, what will happen? The line conductor. See, this is going to be of the line conductors. This is my line conductor. See, this is going to be of my line. So this is my line. Okay. So this line conductors, which is the disk, which is going to be of nearer to this line conductor, will have the maximum voltages. Sure, definitely. Why? Because so the line, if suppose line is going to be often carrying off on 110 voltage means 110 kilovolt of voltage means, so this disk is going to be of a more stress. Because but obviously the line conductor which is near to the disk will have often maximum voltages. Okay. Automatically what will happen? The charging current through this string will be have the maximum voltage across the disk, which is going to be of nearest to the conductors. Okay, suppose I am taking this going to be of my V1, and this is going to be of an V2, and suppose this is going to be of an V3 means the V3 voltage will be more than your V1 and V2, will be more than your V1 and V2. Okay, so here we are going to calculate, here in the but we are going to calculate mathematically, here we are going to calculate mathematically, we are going to calculate what will be the voltage distribution in our strings. Voltage distribution in our strings. So based on that, we can able to calculate what about the string efficiency. What about your string efficiency? Okay, so the string efficiency is going to be often very, very important. So if the string in the if the string efficiency is going to be often more means the greater will be the uniform distribution of your voltages. So the life of your the insulators will becomes more. The life of the insulators is going to often comes more. So here on the so due to since the capacitance is going to be often there will be there in your suspension type of insulators, the voltage distribution of the insulator string has to be calculated. So how we are going to calculate it? We have to know about what is a mutual capacitance and the shunt capacitance in your strings. So then only we can able to calculate the voltage distribution in the insulator strings. So for that we are going to write the what is a mathematical expression. So for writing the mathematical expression, this is how we are going to convert these insulator strings into an electrical network. So once if we draw the electrical elements, we can apply the mathematical concept of which is current law. Then we can write the equation. Then we can able to calculate what about the voltage distribution. We can able to calculate what about our voltage distribution. Okay. So this will have the many, but based on that string efficiency, we can go with respect of the methods how to improve the string efficiency. We can able to go for of the methods to improve the string efficiency. Okay, so we'll derive the mathematical expression for the voltage distribution in your string. So based on that, we can able to calculate what about our string efficiency. Okay. So this is our cycle. This is another one type of how the cycle insulator is going to be often placed. And this is our stay insulators. So this stay insulators normally you can able to see you are in the distribution transformer, near to the distribution transformer or near to the electrical pole which is available in your near your home. You can able to see about this type of stay insulators or the stay insulators. Okay. So stay insulators normally will be insulated from the ground at a height of 3 meters. It will be used for your low voltage line nearly about 33 kilowatt. So normally here also it will be easily made up of your porcelain and it is designed that it should case of breakdown the stay wire will not fall on the ground. So that's type of things is nothing but it's going to be called as of your stay insulators. Okay. So we'll do the mathematical expression for the suspension type of insulators after this completion of the types. Okay. So what are the various tests we used to perform in our insulators? What are the various tests we used to perform in our insulators? First is going to be the mechanical strength test. Is nothing but whether this insulator has often high mechanical strength, then only it can able to be but carry the conductor and but can able to stay on the tower. Okay. Next is going to be of the insulation test, electrical insulation test. In the event to avoid the flashover and puncture. Okay, then environmental test, corona test, a temperature test, puncture voltage test, and porosity test. Why? Because if the having of a more porous, it means the insulator should be of a non-porous. Okay, so that's why we'll have of the porous test will be there to check how many. But if more impurities and porous are there, means then we'll reject the type of insulators and we won't place it in our tower. Okay. So before the insulator is going to be often used in the live system. So we'll carry out the various tests. So that various tests are nothing but the mechanical strength test, electrical insulation test, environmental test, corona test, temperature test, puncture voltage test, and porosity test. So these are the various tests which is going to be often performed on the insulators. Okay, to test about the dielectric strength, mechanical strength, and the permeability. So I have explained what is the causes for the insulation failure. So one is going to have the flashover. So the most common of the insulator failure is nothing but it's going to have the flashover. Okay. If there is often crack, so then the expansion of steel or porcelain and cement during the wearing condition of the cold environment, there will be often crack on your insulators. That will also one of the causes of your failure of the insulator. So then we have to replace that insulators. Okay. And third is nothing but the porosity of the material. So then it will absorb the moisture from the atmosphere. So what automatically the insulation resistance of the material will be comes down. So short circuits may be happen in the insulators also. Two or more conductors on the number or the air through the larger belts. Then the short circuit may lead to the failure of the insulation. And the mechanical stress that also the breaking of the insulator may happen. Heavy mechanical stress that leads to of the breaking of the insulators. Okay. So these are the various causes of your insulators. In the causes of insulators, main thing here in the you have to know about what is a puncture, what is maybe often flashover, and what about your safety factor. This is very, very important in your causes of your insulation failure. Okay. So that's all with the different type of insulators. That's all with the different type of insulators. So next session we'll solve but we'll see that how to derive the mathematical expression for the voltage distribution in a string. Voltage distribution in a string we'll discuss. Okay, so based on that we'll calculate the string efficiency of our suspension type of insulators, because the string efficiency is going to be often very, very important in our suspension type of insulators. Okay. So any doubt? Any doubt?
சார் இன்சுலேட்டர் ஃபெயிலியரில் 4 பண்ண மட்டும் சொல்லுங்கள் சார்.
இதுமா
insulator failure. ಅಲ್ಲ fourth point போட்டோம்.
Fourth point. I'll come back to these slides. Yeah, short circuits. Two or more. You're asking about this one, no? Short circuits.
Yes, sir. Yes.
So, என்ன ஆகும் பார்த்தீங்கன்னா நார்மலாக வந்து பார்த்தீங்கன்னா we'll have the tower. Okay, we'll have the tower. So in the tower we'll have the cross arms. So we'll have of nothing but, so suppose in case of nothing but 11 kilovolt or 33 kilovolt transmission line. Assume this thing, but I am having of 11 kilovolt or 33 kilovolt transmission line. So we will use of the cross arm. In the cross arm we'll place the insulators. We'll place the insulators that is going to be often glued here. So this is one insulators for one phase, other phase, and third phase. This is going to be often glued. Okay, and here the conductor is going to be often placing on the on the groove. Okay, so suppose nothing but what will happen, but based on the voltage level, the clearance will be different. Based on the voltages, the clearance between the conductor is going to be often varies. This clearance is going to be often gets varies. This clearance. Okay, suppose sometimes you can see that nothing but the birds will be often sitting on the conductor, live conductor. But if the birds are sit on your but on a single conductor, it won't get affected because there is no path for the flow of current, so that won't get affected. Okay, suppose a group of birds are sitting, coming and sitting on these live conductors. What will happen? They will occupy the conductors, three phase of the conductors, or maybe the two phase of the conductors. Right? Suppose in the group of birds, one bird is trying to fly from that one. What will happen if the gap, the spacing between the conductors is going to be often 2 meter or so the wings may be touching the both the spaces. What will happen? So there is a path for the flow of current between the face to face or line to line short will be there. So when there is a line to line shortage, what will happen? There is a heavy flow of current will be there. Then the voltage, this current may have causes the flashover on the insulators. Okay, so that will, here we are calling softening, but the short circuit leads to the flashover in your insulator. That is we are calling here is going to have the flashover. If the repeated flashover is happening, there is chance of puncture may be happen to these insulators. So when puncture happen means then we have to remove that insulators. So because dielectric losses is property, insulating property will be lost. So then we have to replace. So that only here I am that's going to causes of the insulation failure. That may be one of the reason is going to have the short circuits. When two or more conductors are earthed. Not only through the larger belts, even that tree, the tree under the transmission line. So if there is a heavy wind flow, the tree may be of touches the two conductors. So there will be of short circuit may be happen. So sometime during your heavy wind or rainy season, you can able to observe so that what will happen? Light will be coming and goes. Flash, right? So sudden switch off and sudden on off your lights will be happen. So that is nothing but due to of a heavy wind or maybe of the rainy seasons. But what will happen? The two conductors are touches to there will be often short circuits. So due to that short circuits also there will be of the puncture will be there on your or flashover, maybe failure of the insulation may be happen. So that only here I have told you as often short circuits. Now you got it.
Yes, sir. Yes, sir.
Yeah. So this is going to be of nothing but what is the insulators, what are the different type of insulators, and what are the causes for the insulation failure. So next session we'll move to the voltage distribution, how the voltage distribution in there. I will explain what is of voltage distribution. So then we'll derive the mathematical expression for the voltage distribution. Then we'll calculate what is the actual voltage distribution in each in a group of string of insulators. Then based on that we can define what is the string efficiency. Then we'll go for the methods of improving the string efficiency, how to improve the string efficiency in our insulators. So with that we'll wind up the insulator part. Then we'll move to our underground cables. Okay. So I think today we are having a transmission distribution CA exam now.
Yes, sir.
Yeah. So any doubt or anything you want to ask regarding the CA test?
No, sir, no doubt, sir.
Okay. So I think I have posted the entire material in the Google Classroom. Both the handed and mixed materials are there. Both the theory and tutorial problems also there. And I have posted the book material also, reference books. One VK method I have posted in the Google Classroom. Another one is going to be a okay. So if you have any doubts, you can ping me directly. I will call you and I will clarify your doubts. Whatever may be the doubts related to our transmission distributions. Okay. Yeah. Thank you. So we'll see you in the next session.
Thank you, sir.